Hi viewers, in this video I will show you how I connected my amplifier and also how I installed my subwoofer box to keep a maximum cargo space in the trunk of my Honda del Sol.
Lately, I had to replace my old Blaupunkt car radio because it was not working properly. I installed a spare one with a USB port and an auxiliary input. The car radio project was also an opportunity to reroute the power wire to make it shorter and reduce the resistance. While I was working under the hood, I had the idea to use the 30 amp free space in the middle of the fuse relay box. The amperage reading shown on the fuse cover was sufficient to supply the amplifier and protect the electrical components. I did not find any specific documentation on how to do it, so it was more convenient to open the fuse relay box and test the electrical continuity between the contacts. First, the battery cables were disconnected and the battery was removed. In this view, you can see my amplifier power wire and also two branches of the main electrical harness. Based on the amplifier specifications, the power output is 180 watts when the wires are bridged. Because a 30 amp fuse is normally required to protect the circuits, it's probably a Class AB amplifier. So I divided 180 watts by 65% efficiency to obtain 277 watts. Then 277 watts was divided by 12 volts to get 23 amps. There was also no problem to route a 10 gauge power wire in my Del Sol. Before looking for connectors under the fuse relay box, I began by disconnecting the main power cables coming from the battery and the alternator. I paid attention to the shapes of the terminals to reconnect them properly later on. Only 3 bolts were used to hold the fuse relay box in place. When the box was free, there was just enough space to rotate it and remove the undercover. I had to unclip all the retaining tabs to be able to undo the part. The locking tab on each connector must be unlocked to unplug them. There was no ID tagging required because each plug had a different shape. I removed the main 80 amp fuse to check the current continuity between the battery and the alternator contacts in the box. Next, I checked if the electrical output side of the empty fuse holder was connected with any other fuse or relay. To check the continuity with the electrical contact tabs located on the opposite side of the fuse relay box, I used an alligator jumper wire to connect one probe of the multimeter. As I guessed, there was a contact tab available to be connected in the 5-cavity connector. Using the circuit located just after the 80 amp fuse, the battery supply and the alternator supply was very efficient. Note, an electrical load detector is installed in the United States to better manage the alternator output. The ELD unit reads the current flow and sends an analog voltage reference to the ECU. There was no contact socket in the cavity. I checked in my wire bundle kit and I found a wire with the proper gauge that was already crimped with a fastened terminal socket. It was fitting in the cavity and it was able to handle 30 amps. To be able to insert the fastened terminal socket in the empty cavity, the contact circuit retainer had to be removed. When the contact socket was in place, I refitted the locking retainer to lock all the contact sockets in place. A bit later, I removed the battery tray to see where the routing would be the most efficient. Routing underneath the harness was the easiest solution. To connect the wires, I used a splicer reducer lag. Once done, I secured it with electrical tape and corrugated loom tubing. To reconnect the plugs, I began with the one that was modified. Then I reinstalled the other ones. The undercover was tricky to put back in place, but at the end I was able to reshape the wire bundle and lock the retaining tabs. Before securing the final routing, I fastened the fuse relay box and I reconnected the main terminals. To ease the work and secure the wires, I used one of the firewall studs to install a plastic wire clamp. I also fitted 1 inch of rubber hose around the second stud to prevent the wires from getting damaged. Next, the battery tray was put back in place and bolted. I reinstalled the battery and, for safety, I removed the new fuse before connecting the battery cables. Everything was fine when I started the engine. There was no problem with any electrical components. After the test, I had a last look at the routing inside the vehicle and I refitted the parts. The routing was also fine in the trunk. My following big task was to carpet my modified ported subwoofer box. The enclosure was reduced to a minimum size because I wanted to easily gain access to my spare tire. The second reason was to keep enough cargo space to be able to carry 2 folding chairs. It was not easy to carpet the subwoofer box because there was many surfaces and different angles. When the box was ready, I put it in place to see if it was fitting properly. I installed 2 custom brackets to secure the box in place. The subwoofer was connected and mounted on the enclosure. It was fastened with 8 screws. At that moment, I didn't use any polyfill in the box. I preferred to wait and try it in the coming weeks. Next, I removed the subwoofer box to complete the routing of the RCA wires. The wires were easy to route with cable ties. Since my Honda del Sol was made in 1993, it was okay to install a classic amplifier from the early 90s. I am not a sound specialist, so this subwoofer enclosure was never designed to be tuned. After, when the subwoofer and the amplifier were installed, the box was a lot heavier and more difficult to handle. Later on, all the wires and the amplifier fuse were installed. In this view, you can see how tight all the components are fitting when the roof holder and the roof panel are lowered in place. To know more about RCA, audio signal, and sine wave clipping, I had MP3 files with 40, 50, and 60 Hz sine waves ready to be played. To test the amplifier later on, I reduced the gain and the bass to minimum. I bridged the speaker wires to use a single subwoofer. To read and display the audio signal, I installed my basic digital oscilloscope in the trunk. An 8-bit resolution from the DSO is good enough to see when the audio sine waves are clipped. I tried different volume levels with the car radio and it was easy to find the maximum level when the clipping was visible. After, I used the low end clamp with the DSO to display the amplifier current draw with different sine waves. As you can see, the current flow waves were directly related to the audio waves from the RCA signals. To check the amperage required with different sound levels, I clamped my ammeter around the power wire. At very low volume, it was measuring around 1 and 2 amps. At normal volume, it was around 10 amps. At loud volumes, it was around 16 amps. It is not shown, but at clipping level, the amperage was around 20 amps. The final gain and bass adjustments were done later during a road trip.
The normal procedure is to connect the amplifier to the positive battery terminal, but the battery and the alternator must be able to handle the amperage and the voltage to protect the charging system.